All right, good morning, class. So this is chapter 2. This is where we're really going to start on, some of the main parts with SolidWorks. So we're just going to go through, just some brief stuff on, um, this part of the lesson, just some of the background stuff on SolidWorks, or some of the tools you're going to use in just this section. So we're only doing, kind of 1/4 of the chapter right now for chapter 2. So we're breaking it down into 4, kind of bite-sized pieces, so you guys will have time to go through this, look at the videos, read through the chapter, if you need some other help step by step, and then also work on the projects or the multiple projects that we have for this section. All right, so the first thing we're going to go through is the housing lesson and some of what's in that. So um, we'll learn how to add a boss or extrusion, which is kind of it's the main part. So right, so it's the boss. So it'll be like the foundation, so to speak, of your part. Fillets, so they're going to be you'll have rounds and fillets, so they're going to be, if you have a corner, whether inside or outside. Um, Usually a round is going to be on the outside, a fillet will be on the inside, but it's just rounding off, a 90-degree turn or corner or something like that. We'll learn how to add a cut and an extrusion. So, once you have your boss, your main part, you can cut a hole in it, or you can add an extrusion to actually add onto it. It kind of molds it all into one part. Add mirror features. So, if you have something on one side of the part, if you want to mirror it on the other, you can do that. Hole wizard. So if you have certain holes that you want to do, like some standard sizes, like a 1/2-inch drill hole or a countersink hole or a counter bore, you could use the hole wizard for all that. You can edit your sketch and any features. You can put in linear or circular patterns. So if you have like a bolt pattern on something like a pump housing, you can do that. So you can have a circular pattern, put it all on there. They'll all be on the same radius. The centers of circles all match up, and they'll be all nice and even and exactly the same. You can add tolerances. So, a tolerance is basically going to say, if my part is supposed to be, 10 millimeters long, my tolerance is going to be plus or minus a 1/2 millimeter. So my part could go from 9.5 millimeters on the small side to 10.5 millimeters on the large side. So that would be your tolerance. Usually they'll be a little tighter than that, a little smaller. I just want to kind of give you an example. And then SolidWorks will actually calculate mass properties. So, after you've modeled your part, right, it has a certain volume. And then depending on what material you assign to it, it'll tell you, what your mass properties are. So, if you made a certain part and you put that it was made out of wood, maybe that part weighs 1.5 kilograms. And let's just say you take that same part and you say you want it made out of, AISI 1020 steel. Maybe that part weighs 4 kilograms now. So it'll actually calculate the mass properties, based on the volume of your part and then whatever material that you've assigned to it. So SolidWorks is a computer-aided design software owned by Dassault Systems. It uses the principle of parametric designs and generates 3 kinds of interconnected files. So you'll have a part file, a .prt, an assembly file when we get into those, so an ASM, and then a drawing file. So once we get a part modeled, you can actually put it into a drawing. It's a super fast process. That'll give you your 3 standard views, so your front, top, and right side, and you can even put in your isometric view, or depending on the part, maybe a section view. So instead of something like AutoCAD, where we've actually had to put those in by hand, SolidWorks will put those in. It'll be based on how you've oriented your part, what face you've drawn it on. So if you've drawn it on the front plane, the top plane, or the right plane, and then how you've extruded it from those planes. So any modification to one of these 3 files will be reflected in the other 2. So, and what that means is, if you draw a part and you put that part into an assembly, and then you save that assembly, and then you also put that same part into a drawing file, so that you can send that to a machine shop or whatever. Those files will all be connected. So then if you make a change to the original part, you have those other 2 files open, it'll make a change to that. So, you won't have to go back and change the file. You don't have to change the drawing. It'll automatically update based on that new size, because it's actually going to pull from that part. So design intent. So this is how your model behaves when dimensions are modified. An Example of design intent is how you create a dimension and a hole in a block. So the hole can be a certain distance from a corner or edge, or it can be in the middle of a face, for example. So why is design intent important? So it allows you to modify your design. They can help reduce material usage, production time, and cost when it comes to prototyping and development. And engineers can run the product design through simulation software to see how well it will hold up in various conditions, which can often identify design flaws. And we'll talk about that part towards the end of the semester. However, with design intent, so with the example they give, let's say you have a feature that's a 3x3 block, and you want to put a hole right in the center of it. So one student puts the hole. They put it exactly 1.5 from the edge on the right side, and then 1.5 from the edge on the top. So the center of the hole again is right in the center. And then we have another student who decides that they want to put the hole based on the center of the block. So they just put it as either the length divided by 2, or let's just say they constrain it to the center of that. Where that would make a difference, so let's say both students have a 3x3 block, they both have their hole in the center, and then both students are told to change their block. So let's just say, hey, now we want the block to be a 5x5. The customer changed their mind, or whatever they're using it for. So the student who constrained it to the middle, right, that hole's going to stay in the center because it's just based on the center of that part. And so no matter what dimensions they went to, if they went to a 5x4 or something weird, or 6x3, whatever it was, that hole would always be constrained to the center. However, the other student, because they've constrained it to the edge, it's always going to be 1.5 units from that edge. So if they change it to a 5x5, now the hole is going to move up into the far corner so that it can stay 1.5 inches from one edge and 1.5 inches from the other, and it's really not going to be constrained to the center. Extrusion, so we'll look at these. So boss extrusions. In engineering, a boss is a protruding feature on a work piece. So a common use for a boss is to locate one object within a pocket or hole of another object. In computer-aided design applications, a boss is a feature used to describe a type of extrusion. The extrusion just means that you've taken something flat that you've sketched and you've given it that third dimension, so you've given it that depth, so you're extruding it. Add fillets, so fillets and round, they create a rounded internal or external face on a part. You can fillet all edges on a face, selected sets of faces, selected edges, or edge loops. And so we'll take a look at all these. Cuts, so you can add cuts or extrusions. So a blind cut would be you can enter an angle value for the cutting operation with the revolve cut command. Up to the vertex, so you can choose a vertex from 3D geometry in SolidWorks. The cutting operation will be done up to this vertex with the revolve cut command. Up to a surface, so you can select a surface inside the drawing, and the cutting operation will be done up to this surface or plane with the revolve cut command. Offset from surface, so you can start your cutting operation from a surface that you have selected. You can also enter an offset value, so if you need to bring that out. Where you want to start your revolve cut operation. This is, you would think, why would you want to offset it from a surface? But if you think of something like if you were going to design a revolve cut for like a screw, right, you wouldn't want that cut to stop at the bottom of the screw. You'd actually want that to continue all the way down, so that you're not really trying to you're not having to guess like where you need to end this cut with the threads. The cut would just keep going all the way around, so that you would kind of get that taper on the bottom thread, and that would allow you to that taper to start as small as possible and then continue on up. And a midplane, so you can make a symmetric cutting operation with this. The angle value that you entered will be separated between two sides of the symmetry plane, which is your sketch contour plane, also in a revolve cut command in SolidWorks. So midplane just means you're cutting it from that midplane, and it's taking it from that middle. Some other features, so origin. So it's always a good idea to start your drawings from an origin. For a sketch to be fully defined, right, SolidWorks needs to know not only all the dimensions that define the size of the part or whatever you're modeling, but also where it is in model space. So if you start your drawing on the origin, right, it always knows that one corner is at 0, 0, and so it always knows exactly where that part is in model space, which helps it to be fully defined. So if you're doing a drawing, you don't start on the origin, and you put all the dimensions in, and you think, well, why does SolidWorks say it's still not fully defined? It's because you need to also tell it how far from the origin it is. So whether you have to go this far to the right and this far up, or wherever you have it, SolidWorks needs to know exactly where that is in model space. So if you can start it on the origin, SolidWorks will know, and it'll save you some time. Circle feature just draws a circle, so there's different ways to do that. Rectangle feature, so you can draw like a midpoint rectangle or an edge rectangle. Slots, so just think of this as like having two holes with a cutout in between. So just exactly what you think of from a slot. It makes it easy to set the length of your slot and then also the height of it, rather quickly. And then if you need to make any changes, the slot tool makes that pretty simple. Mirror features we talked about. Hole wizard, we talked about that a little bit also. So again, if you have some, hole you need to put in there, and you need, you have some standard dimensions you want to use, you can use the hole wizard, and it gives you a lot of options to do that. Edit sketch. So if you need to go back and edit your sketch and change some of the features, you can always go back and do that. So even though if you have the part modeled and extruded, you can go back to your sketch and change the size of some of the features, and the part will automatically update because this is a parametric program. Linear and circular patterns. We talked about tolerances and mass properties. Geometric relations. So these are some things you can actually use to constrain your part. So think of this as like, if you had a cube or something like that where all the sides are equal, and you're doing your sketch, you can constrain all four sides, right? You can say all four sides are going to be equal. You can tell SolidWorks this, and that way you only have to dimension one side. So you can say, hey, all four sides are equal, and I want my sides to be 2 inches. So after you tell SolidWorks, hey, these are all equal, you can put one side as 2 inches, and they'll all go to that same dimension. So sketch entities such as a line or point will remain horizontal with respect to the horizontal axis. So you can set a horizontal constraint. You can do vertical constraints so that it's always a vertical line. You can make 2 or more sketch entities that are always parallel to each other. So this is beneficial if you're having to do like a hand-drawn slot or something like that. Sketch entities will remain 90 degrees to each other, so you can set them as perpendicular. You can make them on the same line. So if you have different sections of the part that you want to line up all the time, you can set that constraint. A point or vertex will lie on an arc or a line, arc, or ellipse, so you make sure it always sets on that line. You can combine 2 sketch points, so if you're just trying to match something up or you go back and do some edits, a lot of times this will come in when you're trying to figure out some type of an arc to put in there. You can combine 2 sketch points just to make it snap to a point you already have existing. A point will remain at the intersection of 2 lines, so you can set it to where it'll always stay at that intersection no matter how you change your dimensions. 2 circles or arcs will share a common center point, so they'll be concentric. And we'll come across drawings that actually have this as a constraint, so that no matter what radii or diameter you put for these, the center points always be shared. 2 circles or arcs will share a common center point, so same thing. 2 sketch entities will remain tangent to each other. 2 entities that have the same length or radius, so equal entities will update when the major dimension is changed, right? So you set them as equal, you change one dimension, they'll both change. The entity size and location are fixed in space, and then two sketch entities such as lines, arcs, or ellipses remain equidistant to a center line. So you can set that, so that they'll always be the same distance from the center line. So think of a chess piece if you're going to model something like that, like a bishop that's perfectly round around the center line, right? And you wanted to, you probably revolve that, but something along those lines where you just want to make sure that everything was always the same distance from the center line. So it was perfectly mirrored from one side to the other. So here are some of those, the geometric relations. I won't read through all those, but it just tells you what all those are for. Dimensioning, so you'll notice when you go through SolidWorks, as you're sketching a part, all the lines will be blue. And in the bottom right corner, it'll say underdefined, underdefined, until you get all your dimensions in. Um, so when you get all your dimensions in, all the lines should actually be black. And then, in the bottom right corner, it should say fully defined, which tells you have all the dimensions you need. There's not going to be any ambiguous parts to it. And SolidWorks knows exactly where it is in space. So you want to look for all black lines and for your sketch to actually say fully defined. If you get to over dimension, it means that you already have a constraint or a dimension that tells where that is. You'll get like the drawing will turn yellow, and you'll get like a caution symbol. It'll tell you it's over defined, and ask you if you want to use that dimension as just a reference dimension, which means it's not going to be driving the part. If it is a dimension that you need, it means you have an extra constraint somewhere. So maybe you have a horizontal line that you don't want horizontal, or maybe something's parallel that you don't want parallel, or maybe something two lines are equal that you didn't want equal. So you'll need to go back and check some of your constraints if you're trying to put in a dimension that you need and SolidWorks is telling you that it's over dimensioned. All right, side cover lesson. So just these are some of the things you're going to go through. So revolve, boss, and extrusion. You learn about construction geometry, which is just geometry you use to put in certain parts, but then you're going to actually erase. Circular patterns, fillets, and then you're going to assign a material. So this is all for the lecture. I've got the videos to go with this, so you'll want to watch the two videos on the housing and the side cover. So I'll post the links to those, and then I'll have the assignments up for Chapter 2, Part 1. And then, if you guys have any questions, let me know, and we'll do Chapter 2, Part 2 on Thursday. All right, have a great day. I'll see you later.